Hey, this is Kenneth, and today we are fixing a 4-port 10 gigabit line card out of a Catalyst 6500 router, well, switch. So if you haven't read my previous blog post, I recently stood up my own autonomous system in a data center using a Catalyst 6506 switch as my router. This is a ridiculously overpowered switch. The platform is about 15, 17 years old, and how it works is actually it's a modular system. The switch is about 12 rack units tall, which is about 2 feet, and then it has 2 power supplies in the bottom, and then 6 slots that you can slide in line cards. And so, one of the line cards is my supervisor that, manages the actual layer 3 routing logic in the switch. And then all the other ones are various switch port options. Right? And so, for example, right here, we've got one that has 4 Zenpack slots for 10 gigabit. Zenpack is a predecessor to... It's a modular transceiver, right? And so the concept is you get the line card with the Zenpack slot, and then depending on exactly what fiber optic transceiver you need, you get the Zenpack to slide in for, be it a SR short range 10 gigabit optic or an LR long range 10 gigabit optic, or like an ER or a ZR, which are like stupid long range, like 40 or 80 kilometers. And you don't need to change anything in your actual router hardware or switch hardware, you just put in a different optic. I don't have any Zenpacks on me here. I think I left them all at the data center, right? But they were essentially the predecessor to SFPs. 1 gigabit SFPs probably existed about the same time as Zenpacks, but getting 10 gigabits into the smaller form factor took quite a while to figure out how to get SFP plus in the same form factor as SFP. This is probably a 1 gigabit LSX. Yeah, so this is a 1 gigabit SX SFP. And so on this side, you plug the fiber optic in, and then this whole thing slides into a switch. So like if I find, yeah, so here's a Catalyst 3560 switch, and on the front of it, it has these 2 ports here that the SFP just slides into. And so whether I only need a few hundred meters of 1 gigabit or 10 kilometers of gigabit or many kilometers of gigabit, I can just swap, hot swap in or out various optics here. Same concept, except instead of being the size of a stick of gum, the optics are about the size of a deck of cards, just because it predates this, and there was a time when 10 gigabit was really hard. So what's the problem? This line card was gifted to me because the heatsink fell off. The heatsink fell off because my friends piled a 2U server on top of it, which was probably bad planning on their part. So, I've given them a hard time. But now we've got the problem that the heatsink isn't stuck on, and that's kind of a bad deal. But before we go into that, let's just talk a little bit more about these line cards, because I think it's kind of interesting. And to start with, let's start with something a little bit simpler than the 10 gigabit line card. Let's start with this line card, which is actually not even gigabit, but fast. So this is 100 megabit copper, and it's a 48 port line card. And so if I decided that I needed 48 fast ports on my switch, I would slide this into one of the slots, and then it would actually come up in iOS as here's your 48 ports. But on the front of it, on the face of it, you've obviously got 48 copper ports. This is a WSX6148 RJ45, since they're standard copper port. You can also get this line card as an SFP line card, so it's, instead of it being 48 RJ45 jacks, or 8P8C jacks technically, it's 48 SFP cages, which would be awesome because I don't have one of those, but so I can't show it to you. But you slide it in, it has the two levers on the side that let you then interlock it in so it goes to exactly the right depth. You screw it in, and you can just start plugging cables into it. Like, my last blog shows a photo of, like, I've got a copper line card with like 4 cables plugged into it. But turning it around, off of the RJ45 on the front, we have 24 transformers. So these are actually dual combination magnetics, and so each one of these actually supports for 2 ports the isolation transformers you need, because Ethernet is a magnetically coupled transceiver, which is great because it means that your 2 pieces of equipment don't necessarily need to be at the same ground potential, and you don't make ground loops through Ethernet because it's all magnetically isolated right here. It's generally not good enough to run Ethernet between buildings because you'll tend to pick up quite a bit of potential between 2 buildings. So typically you won't want to use copper Ethernet between 2 buildings. That's where fiber gets real attractive. But these are your magnetics. And so you've got your 24 sets of essentially, you know, transmit and receive transformers, which then run down to these 6 ICs here, which are Broadcom BCM 5218 C3KTB Ethernet transceivers. And so these are going to have each one of these 8 transceivers to drive these magnetics, and plus some sort of fabric on the back end to combine them all together here. I haven't bothered doing much research on this because Cisco tends to use so much of their own custom silicon that I didn't really expect to find much useful stuff, and even just finding info on Broadcom transceivers tends to be a pain. But what Cisco really got right on the 6500 series was how modular everything was. I mean, that's the reason. It's one of the main, big reasons why the 6500 series family lasted so ungodly long. And so you'll notice that there's these 3 extra connectors on here. This was actually for a daughter card that plugged in on the top here for power over Ethernet. And so if you, instead of wanting 48 copper ports on the front, you wanted 48 copper ports with power over Ethernet for powering like phones or access points or webcams, you literally just had to plug in the daughter card here to add PoE support, and then boom, this was 48 PoE fast Ethernet ports. So that's what went here. Then you've got your switch, ASIC stuff, plus bus transceivers onto the backplane, this was a 32 gigabit shared bus between all of the line cards. And so obviously you can't have full gigabit coming in on all 48 ports since it's only 32 gigabits on the backplane. And I really want you to appreciate how many pins there are on this connector. It's crazy. And so all of the 6500 line cards have this block here with your bus transceivers. So this is your kind of data pathway into the backplane of the chassis, which if I had a spare chassis, I'd show it to you, but I obviously don't. And then this is the power supply block over here. And so again, on the backplane, there's a 42 volt rail, which this is the beefy connector for. So you'll notice that has just a few really big pins. And then this part is a voltage regulator that steps that down to whatever you need here. And this tends, like the power in these chassis is really beefy because if you load the whole chassis with power over Ethernet line cards that are pulling 15 or 30 watts per port, you can easily get into several kilowatts. And so like my chassis happens to be configured with 2 3-kilowatt power supplies, and the backplane supports like 92 amps at 42 volts, which is just a stupid amount of power. But it's so that you can, if you configured the switch in a configuration that was lots and lots of devices pulling DC power out of it, it's possible. So this is a fast card. This is like literally my e-waste, and we're not fixing that. We are fixing this one. So someone piled a 2U chassis server on top of it, which broke off the thermal tape, like thermal pad, sticking it onto this Cisco ASIC here, which I couldn't find any information on this. It says 08-0559-03 Gemini. So, but what we do know is that this card here, you'll notice this is actually up on a raised card. This is the distributed forwarding card option that is modular with these line cards. So the 6100 series line cards, like this fast one, that's a 6148, didn't support this, but on the higher end stuff, so this is a 6704, as there's 4 ports and it's a 67 series line card, supported this thing called a distributed forwarding card. And this was what really made this switch so, well, one of the many things that made this switch so phenomenally powerful is that this daughter card allowed you to upgrade these line cards so that they could actually make the forwarding decisions themselves without having to check back in with the supervisor. And so it essentially was all of the packet forwarding ASICs that would be down at the bottom of your chassis on your supervisor, you would duplicate that on this line card, and the supervisor would upload all the forwarding and routing information onto it, so that if a packet came in on one of these ports and this line card could figure out that it went out one of the other ports, it didn't have to go bother the supervisor over what you will notice is an upgraded backplane connector here. Since this is 4 10 gigabit ports, a shared 32 gigabit bus across the whole backplane wouldn't have been sufficient, and so on these higher end cards it actually uses a dual 20 gigabit fabric, and so there's 40 gigabits going into this line card that could go out. And so if this line card needed to forward packets to another line card, it would go out through the fabric, and it's unclear exactly how the backplane handles the traffic. But this daughter card comes in several variants. The lowest end one, which is what we happen to have here, is called the CFC. The part number for it is WS-F6700-CFC. And the CFC daughter card here essentially just turned this whole line card into like a 6100 series, in that it made no forwarding decisions at all and just dumped all the packets onto the supervisor and said, please help. And so the supervisor would have to do all the forwarding decisions for an entire chassis worth of line cards with CFCs, where if you upgraded it to a DFC, like a DFC3B or a DFC3BXL, the supervisor could upload the routing table into the option card here, and then it would be able to do the forwarding itself. The difference between the 3B and the 3BXL is that the XL daughter card can handle 1 million routes, where the 3B can only handle 250,000, which I actually have a full internet table on my router, which is about 700,000 routes, I wouldn't be able to use a DFC3B daughter card here, which is what you see in most of the cards on eBay, because the DFC3B XL card is more desirable, and so people grab them faster. Because my supervisor has a PFC3B XL 1 million route forwarding engine in it that doesn't fit in that. But since this is a CFC, I can use any supervisor with this, because the CFC is just essentially just glue between 10 gigabit optical transceivers and backplane to the supervisor. So if I start using this line card, my supervisor will see more routing load on it, because all the 10 gigabit traffic will be going back to the supervisor. A counterpoint being the SUP 720B that I have can handle 40 million packets a second, which is stupid fast. And so there's really gonna be no problem. But there's 5 screws holding this thing down, and there's actually 2 levers here that release all of the all the high-speed connectors here, which are very similar to the backplane ones. Again, as an electrical engineer, I have a lot of appreciation for just how amazing these connectors are for, you know, shoving 40 gigabits in and out from the CFC card between your transceivers and your backplane. Which, one thing I did also appreciate about this 10 gigabit line card is these bus transceivers are actually in very, very rectangular integrated packages, integrated circuit packages. And so these are, presumably the bus transceivers for the backplane here, which are Cisco custom silicon in a very, I guess like DRAM is in kind of a rectangular ball grid array package like that. But these are, I think, remarkably large compared to other integrated circuits I've seen like that. But, you know, whatever. And then lots of heat sinks for all the various glue logic and stuff down here. And there's also, interestingly, like 512 megabytes of RAM, DDR1 RAM on there, which I'm unclear on what that's for, but it's there. Presumably, that might be about how much packet buffer there is. That might actually be the packet buffer for this. But yeah, there's a lot going on here that, due to the many heat sinks on here, I'm unclear of. But we're going to work on this. So let's zoom in on just the CFC and get it put back together so that if I decide that I want 4 more 10 gigabit ports on my switch, I could install it if I wanted. So like I said, the problem here is we've got a disconnected heatsink. The heatsink is presumably pretty important, and how it was stuck on was with a thermal pad. Unlike a typical CPU heatsink that you see on a computer, those would typically have like 4 mounting posts or some sort of crossbar holding it down. But on these line cards, you'll notice that they don't go through the trouble of putting four holes into these boards to violate them, which tend to be relatively challenging from a board design perspective to, plunge giant holes all the way through the board. And they've already had to do that several times for all the mounting holes for this daughter board. And so anywhere that they can get away, particularly in like a non-user serviceable, inside a piece of commercial equipment, they just went to the, double adhesive thermal pad sticking on there, which, thank God that's what they used, because if this had been like thermal epoxy, the server stacked on top of this loose line card probably would have removed the integrated circuit from the PCB instead of the heatsink from the integrated circuit. Although, I hadn't realized it's kind of an intense integrated circuit. It kind of looks like it's kind of through hole, but it isn't. Hadn't actually looked at that. That's kind of interesting. But anyways, so we need to stick this back on there. I kind of debated whether I wanted to try and get another piece of thermal tape or thermal epoxy, and kind of put out, asked the question on Twitter, and everyone came back and said, or several people came back and said, I did notice the other people that recommended thermal tapes, but Arctic Silver's Arctic Alumina thermal adhesive. So it's a 2-part epoxy designed to stick heat sinks to integrated circuits. So that's what we're going to use. So first step is going to be just removing that which is already on here. So I think a razor blade will probably get most of this off. So I don't have any immediate plans to use this line card in my switch, since I already have actually one 10 gigabit line card, which is currently used between my file server, the two hypervisors we have in the rack, one of them being mine and one of them being my friend's. And then the fourth 10 gigabit link is actually set up as a peering link to another autonomous system in our aisle, which is kind of silly because there's no way I'm ever going to be pushing 10 gigabit of traffic across a peering link, considering that like my full transit link is only 1 gigabit. But we really saw it as an opportunity to just play with more 10 gig, and 10 gig is awesome. And we had spare line card slots and optics laying around, so why not? And so, like, really, if I had an actual need for more 10 gig, the first port that, you know, would be, you know, downgrading my peering link down to 1 gig immediately, and so there would be one port, and then I guess I could install this and get 4 more, but at that point we're talking about more than 4, you know, high performance servers in a rack run by 2 guys. So I think the chances of us actually getting there anytime soon is pretty low. So I don't know exactly how I want to get the rest of this off. Or if I want to, we're just going to take some isopropyl alcohol and clean this up, because we want this to be nice and clean for the sticking on part. So that has me a little bit concerned that there seems to be like a weep hole there. Kind of wondering if this package needs to be vented. I mean, the old thermal tape was on it, so it'll be fine. I mean, worst case, I ruin it. I ruin the free line card that I don't really need. So I don't think that's too big of a deal. Grab a clean room wipe. So clean all that up. So I think it really is just going to be mix the epoxy and then stick her on. I think the biggest concern is I just need to be cognizant that I don't block off those screw holes, because if I blocked off that screw hole, I'd be screwed. Sorry. So yeah, it's going to be something like that. Cool. So, a pair of scissors, 2-port epoxy. Ironically, this will probably actually end up being more thermally effective than the probably about 10-year-old thermal pads on there. Since Zenpak was like the predecessor to X2, which I think was the predecessor to something else that was then the predecessor to SFP Plus, and SFP Plus for 10 gig is now pretty ubiquitous. So like I had never even heard of Zenpak before I got into the 6500 router game. So the thermal pads on here were probably pretty old, and I don't know if they get dried out or anything, but they were probably far from ideal. They were probably far from ideal in the first place, since they only needed to be good enough to, you know, sell the product. And so I would not be overly shocked if I could actually, in the telemetry on the router, see a cooler, I probably want more than that, see one of these ASICs be cooler than the other one, which would be kind of amusing. I don't know about that much. kind of feel like I'm going to lose more epoxy to mixing than I am actually needing on the, I guess I didn't read the instructions. Is there instructions with this? Premium adhesive, electrical isolator. Temperature range, -40 to 150. Features, adhesive, use a layered composite. Is a pure electrical insulator, blah, 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 blah. Specifications, a set of Arctic alumina contains 2 tubes containing 5 grams, 2.5 grams of part A and 2.5 grams of part B, and a plastic reusable mixing wand. Warning, caution, it's a permanent adhesive. Don't use this on your consumer CPU, because you gamers love to get up in the business on this product online and bitch in the reviews about how there wasn't enough warnings everywhere about how permanent this is. Jeez, it's a little bit dried out, you might say. Just gotta, you know, break that apart a little bit. Oh, much better. Oh, there she goes. Cool. There is part B. Okay, good. I doled them out in the right order. Because, you know, if you put the part B down on the mixing card first, you actually ruin it. It's no good then. So I'm going to assume that the mode of operation here is mix the heck out of it and then apply to device. Seems like kind of a safe bet on this, considering that they didn't give me any instructions, which is outrageous. I should get on the reviews with all those gamers and complain about what an awful product this is. Even though for $6 I'm fixing like a, I guess on eBay I could pick up this line card for probably about $100. Plus the 3 optics that this one came with, which would be another $100. MSRP would be several thousand, many $1,000. So, you know, I figured the $6 and this evening of fixing this line card was actually, in retro, you know, ultimately a pretty good deal for 10 gig. Honestly, the biggest impediment to me actually using this card is the fact that this 6704 line card actually burns 400 watts, which I have plenty of power. I've got 6 kilowatts of 208 into the rack, but 400 watts for 4 10 gig ports just seems silly to me. Just seems excessive and a little environmentally inconsiderate. And so it's like a lump in there. I don't know if I really am sold on this whole lump business. And so I kind of don't want to run this mainly from an environmental perspective. But short of someone else gifting me a like 24 port SFP Plus switch, which I know that some of my viewers have gifted me things like that before. But short of someone gifting me a kind of medium density 1U SFP Plus switch, this is really, you know, I'm gonna dance with the line cards that someone's gifted me already. So if you want to save me like 300 watts in my rack, and you just have a SFP Plus switch that's just kind of laying around doing you nothing, by all means, please contact me. So I think ultimately I might have been a little stingy, but that kind of seems like a lot. I don't know. That seems like a good, wholesome coating. Well, we've now committed to sealing that hole, so I hope that hole isn't important. Ta-da! So let's take this heatsink and very ceremoniously stick her on. And I'm going to want to make sure that it's straight, because if this thing is crooked, it's going to bother me forever. Even though I'll only see it while installing it, and then I never see it again. Which is kind of one of my complaints about working on stuff like repeaters and routers and data centers, is I get to work on all this cool stuff, and then I never see it again. Because it's like somewhere useful, doing something useful. So I think we will, just to level it out, maybe reinstall it on, probably could have been doing the work on here in reality, but I'll just, yeah, that's not right. Yeah, that seems fine. I'm kind of pleasantly surprised how tacky that is, but yeah, so there we go. Must be straight. Must line up with other one. Cool. Ta-da! I think that's fixed. I think at this point we have fixed it. I guess once this dries, at some point I'll go in the data center and I will power this up. You know, plug it in and see what it does. Yeah, there we go. Weigh it down. We'll weigh it down and plug it in, see if it powers up, see if it blows up my whole router, in which case I'll be a little bit sad. But yeah, so hey, thanks for watching. Thanks for joining me tonight. Just hanging out, fixing a line card. And I appreciate you watching, and I'll see you next time. Bye.